All right, today we're going to actually get you more into the actual probability of the section, so more of the heart of the chapter. So 10.3, we're going to specifically talk about different types of probability. That first type that we're going to talk about is odds. Okay, a lot of times on TV and sports and cards, a lot of different things, you hear people talk about what are the odds? What are the odds of winning? What are the odds of him doing this? What are the odds of this? Okay, when we're doing odds, they're talking about a ratio, and it's the ratio of what you're in favor of versus what you're against. Okay, and when you hear the word ratio, what do you think of? Something over something. So it's what you're in favor of would go on top, what you're against goes on bottom to make your odds. Now, when you're doing your odds, make sure you understand this is going to be a little bit different than the probability we're going to talk about in a second. The odds together, so what's on top and what's on bottom, will give you the total number of your options. Okay, so if I have 10 cards and 5 of them are black and 5 of them are red, then my odds of drawing a black one are 5 black over 5 red. Okay, so the odds are 1 to 1. Okay, so that'll make sense hopefully as we do a couple examples, but the total numbers, so what you have on top and what you have on bottom, give you your total number. Okay, so an example, a card is drawn from a standard deck of 52 cards. Find the odds in favor of drawing a 10. Okay, so again, keyword right here is we're finding the odds. So the odds in favor of drawing a 10. So we said we want to write a ratio. What are we in favor of on top and what are we against on the bottom? Okay, so a deck of 52 cards. Now we got to remember our cards. How many 10s? Okay, how many non-10s? But let's even make it one step a little bit more simple than that. Favor of drawing a 10. So we want a 10. So that's what's going on top. So what we want is our 10s. That's going to go on top. So what do we not want? What are we against? Anything that's not a 10. So our odds are, what do we want? A 10. And then what do we not want? Anything else. So my non-10s are on the bottom. Okay, so now go back to that question. How many 10s are in a deck? Well, there's 1 10 in each suit, right? There's 10 of hearts, 10 of diamonds, 10 of clubs, 10 of spades. So how many 10s are in a deck? 4. And 52 does not go on bottom. The non-10s go on bottom. So if there's 4 10s, how many non-10s are in the deck? 48. Because remember, what did we say? When you're adding up your odds, they give you the total. So there's 4 10s, 48 non-10s, and then always reduce. So your odds of drawing a 10 is 1 to 12. So 1 out of those 12 cards will be a 10. Okay, so let's do another one. Odds against drawing a club. Excuse me. So we're still doing odds, but this time, the first time it said favor, this time it says against. Okay, so we got to kind of think about this one backwards. Against drawing a club. So the clubs are where? Remember, we want favored on top, what we're against on the bottom. So where are the clubs? The clubs go on the bottom. We're against drawing a club. So the clubs are on the bottom, which means the non-clubs is what we want. Okay, against drawing a club. So we want the non-clubs against a club, so that's on the bottom. That's what we don't want. Now, clubs is one deck, or I'm sorry, is one suit, right? How many cards are in a suit? 1 through 10, Jack, Queen, and King. So how many clubs? 13. How many non-clubs? Well, there's 3 suits that are not non-clubs, right? So 3 suits means 39 cards. 13, 13, and 13. So there's 3 suits, or 39 cards that are not clubs, 13 cards that are clubs. So the odds would be 3 to 1. And now when you're talking about odds, you're never going to see this written as just 3, because 3 over 1 is 3. Because when you're talking about odds, you're saying something to something. What are the odds? Blank to blank. So we would leave it like this. The odds are 3 to 1. okay? Now, taking the odds, now we're going to talk about probability, and this is going to be a little bit different than what we just did. The probability of an event is a number between 0 and 1 that indicates the likelihood that the event will happen. So take a guess. It's between 0 and 1. It's going to indicate the likelihood, so which means one side, it is definitely going to happen. The other side, it's not going to happen. So what do you think about 0? Is that it's definitely going to happen or it's not going to happen? 0's it is not going to happen, which means what's 1? 1 is it will, or it is certain to happen. So what does that mean about the middle? 0.5 can go either way. If we're at 1/2, it can go either direction. So it's equally likely to occur versus not to occur. Now, when we're talking about probability, you're going to see it in a lot of different ways. Okay? Probability can be expressed as a fraction, a decimal, or a percent. So 3/4 is the exact same thing as 0.75, which is also the exact same thing as 75%. So when you're looking at answers and when you're writing your own answers, make sure you understand that. You can write them any of these 3 ways, whatever way makes more sense to you. Okay, so what does that mean about this top up here? If I were to think about it in percents, what would this mean? If something's not going to happen and it has a 0 probability, that's a 0% chance. If it is certain to occur and it's got a probability of 1, what's that as a percent? That is 100%. Remember, 1.00 is 100%. So what's a half? If it's equally likely, probability is 1/2. What's that as a percent? It's 0.5 as a decimal, so as a percent, it is 50%. Okay, so again, you can see it any way, you can write it any way. Whatever method makes most sense to you. Okay, a couple basic ones. What's the probability of rolling a 7 when a single die is rolled? Okay, there's nothing tricky to this question. What numbers are on a traditional die? 1, 2, 3, 4, 5, and 6. So what is the probability of rolling a 7? Is there a 7 on a die? No. So the probability is 0 out of 6. So the probability is 0 or 0%, however you want to write it. What is the probability of rolling a number less than 7 when a single die is rolled? Well, what numbers are less than 7? 6, 5, 4, 3, 2, 1. Well, what's the probability of rolling one of those numbers? 6 out of 6. If you want a number less than 7, you're going to roll one of the numbers that's on the dice. So the probability is 6 out of 6, or 1, or 100%. Now, this is called theoretical probability, when the outcomes are equally likely. Okay, so you're taking a scenario and you're giving it a theoretical probability. Okay, and that theoretical probability means you're not actually physically taking a dice in your hand and dropping it, where anything can happen. Okay, so theoretical is theory. In theory, what are the chances? What's the probability? Okay, and you're going to do exactly what we just did on the last 2 examples. What is possible? That goes on top, versus what's the total? That goes on the bottom. Now, you can determine probability of an event mathematically without having to perform the experiment. And that is exactly why this is called theoretical, okay? Based on theory. Theoretically, what should happen? Okay, which means they are equally likely. You're not actually dropping the dice yourself or tossing the coin yourself. So everything is equally likely when you're talking about theoretical. So an example, a spinner has 8 equal-sized sectors. So there's 8 different sections. They're numbered from 1 to 8. Find the probability of spinning a 6. Okay, well, what's our probability? How many 6s are there? 1 out of how many options? 8. So my probability is to roll a 6 is 1 out of 8. Okay, do I have to change it to a decimal? Remember, no, it's the same thing. So you can write this as 1 out of 8. You can write this as 0.125, or how could I write this as a percent? Move it over, this would be 12.5%. How about the probability of spinning a number greater than 5? And if you need to write it out, write it out. What numbers are greater than 5? 6, 7, and 8. So what's our probability? What out of what? A number greater than 5 would be 3 out of 8. You could leave it as 3 out of 8. You could change it into that 0.375 or write it as 37.5%. Now, what's the probability of drawing a club from a deck of cards? Well, club, remember that's one whole suit. So we said that a minute ago. That's 1 through 10, Jack, Queen, King. So there's 13 clubs. And then what's the total? 52. So our probability is 13 out of 52, but reduced, remember if you can, 13 out of 52 is 1/4. So you can write 1/4, 0.25, or 25%. Now, this is different than odds. Remember, probability is what do you have? What are your options? 13 options out of the total, 52. If this was odds of drawing a club, it wouldn't be 13 out of 52. If this said odds, it would be 13 out of 39. Because remember, when we talk about odds, it's what you're for versus what you're against. Against is 39 cards that we would be against versus probability. What goes on the bottom? Total. The total is on the bottom. So do not get those confused, okay? Probability and odds, they're a little different from each other. Now, using NPR and NCR in probability. A community center hosts a talent contest for local musicians. On a given evening, 7 musicians are scheduled to perform. The order in which the musicians perform is randomly selected during the show. What is the probability that the musicians perform in alphabetical order by their last names? Okay, well, first thing, probability. So we need to know what is possible. Remember, it goes on top, and then the total goes on the bottom. So my possible is that alphabetical order. How many ways can they be in alphabetical order? And again, what goes on bottom? The total. Okay, well, how many ways? If I have 7 musicians, how many different orders can I put them in alphabetically? There's only one way to order people alphabetically. Okay, so our top is just going to be 1. There's one way to do that. On the bottom, if I have 7 people, how many different combinations can I order them with? 1, 2, 3, 4, 5, 6, 7. How many people could go first? 7. How many people could go second? 6. How many people could go next? 5, then 4, then 3, then 2, then 1. So what's an easy way to figure out our total combinations? 7 factorial. So alphabetically, there's only one way to put them in alphabetical order. And then that total combination is 7 factorial. So type that in, you'd get 1/5040. And if you pushed it as a decimal, it would be 0.000198. Now, this next one's a little bit different. You are friends with 4 of the musicians. What's the probability that the first 2 performers are your friends? Okay, again, remember what is possible versus what's total, because this says probability. So possible. The possibility that we're looking for this time is the first 2 performers being your friends and the total on the bottom. Okay, well, how am I going to do this one? What is the possibility of me picking a friend? The first 2 performers out of 4 performers. Okay, but is this going to be a permutation or a combination? We've talked about both of them. I want to pick two performers. Does it matter, two performers that are my friends, but does it matter which one I pick first? Does it? No. So order does not matter. So since order does not matter, we're using NCR. So how are we going to write it out? What's our probability of picking that friend? What out of what? I have 4 to choose from, and I want to choose the first 2 performers. So that's 4, choose 2. And then what's the total? I've got 7 musicians, and I'm choosing 2. Okay, so that's our probability. You type it in. Remember, your calculators can do this stuff for you. 4 choose 2 is 6. 7 choose 2 is 21. And if you wanted this as a decimal, it would be 0.286. Now, we've done mainly theoretical probability, and we said theoretical is equally likely, okay? Just on theory, what is bound to happen? But experimental does not have to match theoretical. Why? Okay, you've all taken science classes. When you actually do an experiment, does it actually happen the way you want it to necessarily? No. If I drop a dice 6 times, am I necessarily going to get 1, 1, 1, 2, 1, 3, 1, 4, 1, 5, and 1, 6 if I drop it 6 times? No. I could, in my experiment, drop it 6 times and get all 6s. Now, theoretically, is that probably going to happen? No. But it is possible. So experimental, you actually have conducted an experiment and you're looking at your results. Okay, so you're looking at the results or you're looking at the history. Now, outcomes are not equally likely. Okay, again, going back to the dice that I just said, it is possible I can drop a dice 6 times and get all 6s. Okay, so it is not equally likely anymore when you're doing experiments. So always, 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 like I said, you have to look at the results, you have to look at the history, you have to look at that data when you're doing experimental. Okay, so here's your chart. Ninth graders must enroll in one math class. The enrollments of 9th grade students during the previous year are shown on the bar graph. Find the probability that a random chosen student from this year's 9th grade class is enrolled in, and then we got 2 options. Okay, so probability, what does that tell us? What are we looking for? What's possible over the total? Okay, so first thing we have to do here is we know our Algebra 1's 87, we know Consumer Math is 36, we know Geometry is 69, and Intro is 51. If I'm doing probability, what has to be on bottom? The total. So that's the first thing I want you to find. How do we find that? Find the total, you have to add them. So do that if you haven't done it yet. 87 plus 36 plus 69 plus 51. Total number of students that we're dealing with is 243. Okay, so when we're talking about the first one, what's the probability of a student doing Algebra 1 or Intro to Algebra? Okay, well, Algebra 1 is how many? 87. Intro to Algebra is 51. So what do I do with those 2 numbers to get the OR? 87 plus 51. So my probability is 138 out of 243, or 0.568. Okay, how about the second? What's the probability of consumer math? Well, how many kids went into consumer math? 36. So 36 out of 243, or 0.148. Okay, so experimental probability, you have to actually look at the results that came from the experiment. Now, the last one, geometric probability. Okay, we got to go backwards to geometry and remember our formulas, but geometric probability is very similar to theoretical. Okay, you're going to do the area of what you want. Okay, so what is wanted over the total. So very similar, except we have to go backwards to remember our formulas. So we have a dartboard, and it says you throw a dart at the board shown. Your dart is equally likely to hit any point inside of that square board. Okay, so keyword, square board. Are you more likely to get 10 points or 0 points? Okay, well, how am I going to answer this question? If I want to know, are you more likely, I have to figure out the likelihood to get 10, figure out the likelihood to get 0, and compare them. So it's two questions, kind of. I got to figure out both of them in order to compare them. So let's start with the 10. How do I figure out the probability of getting a 10? Well, the 10 is this inner red circle. So how do I figure out the probability of that? What did we say? It's the probability of what we want over the total. So what we want is this inner circle, okay? So I want the circle on top versus the total. Well, the total's the board, and what did we say about the board? It was a square. So what we want is the area of that smaller circle, or that red circle, and the whole thing on bottom, so the area of the square. Okay, so again, go back to geometry. How do I find the area of a circle? Pi r squared. How do I find the area of a square? Side squared. Okay, and I only want the small circle because I'm looking at the 10 points, remember? So how do I find the area of the 10 points? Pi r squared. Well, what's the radius of this inside one? 3, so that's pi 3 squared. And the bottom, side squared. What's the side of our board? 18. So 18 squared. Type it in, and again, type it in separately, or make sure you have parentheses on top and bottom when you're typing it in, or use your alpha y equals to do your fraction. You type it in, the probability is 0.087. Now, finding the probability of getting a 0 is a little bit more challenging. Okay, why? Where is the 0? The 0 is the 4 white sections. Okay, and those are not triangles, so I can't find them in a sense of a triangle because these are not straight lines. So, how am I going to do this? The probability of getting the white, of getting the 0, how am I going to get this? Think about it. If I can't find the white, I have to get rid of everything else. What do I mean by that? I can find the area of the whole thing. That's 18 times 18, right? And then I have to get rid of all of this stuff in the middle. So I'm going to have to find the area of the circle and then get rid of all of this. So then I have to subtract the big circle. And that's going to leave me with those 4 white sections. So what I want is just the white. So I have to do the square minus the inner circles. And then the total is the area of that square. Okay, so what do I have? Area of the square is 18 times 18, 18 squared. Area of the big circle. So what's the radius of the big circle this time? From here to here. So the radius is 3, 3, 3. So the radius is 9. So 9 pi 9 squared. Divided by area of the square, 18 squared. Again, use your alpha y equals. If you're not, use your parentheses. Probability is 0.215. Now, when you're comparing, it may be easier for some of you to compare these as percents. Okay, so if I want to compare these as percents, pull these decimals over. So that's 8.7% to get a probability to get a 10. Or pull this over. This is a 21.5% probability to get a 0. So which one of these is more likely to get a 10 or to get a 0? You are much more likely to get a 0. 21% versus 8%. Okay, so a lot of different kinds of probabilities. Traditional probability, theoretical, geometric, and odds. Okay, they're not hard, just try to make sure you don't get them confused. Make sure you determine which one is which, and then remember what goes on top, what goes on bottom, and you should be fine.